हेलो मैम। हेलो। Hello students. We are continuing again with our unit number 1 and topic number 3, which is Geographic Information System GIS, Human Development Index and Ecological Footprints. So what do you understand by GIS, that is Geographic Information System? So GIS is an information system which shows information in the form of geographical map as interface data. So GIS is a set of concepts of layers and its relations. So GIS is developed using internet technology, which is called as web-based GIS. GIS will give easy access to its users or decision makers to make any policies. GIS has been widely used to access any information about a certain location. So GIS, as you can see in the picture, GIS can be used for apps, also for area related informations and satellites, software, data analysis and maps. Next, applications of monitoring systems based on a GIS. So there are many different types of monitoring systems. Many of them automate the process of data collection and pre-processing, which is a task often hidden from the ordinary user. Like ordinary users means users like us who doesn't have any idea or any knowledge on monitoring any particular system based on GIS. So monitoring itself may be implemented in several different ways depending upon the type of system under the study. So when designing an environmental monitoring system, the following factors should be taken into consideration. So in our subject, we'll be studying about environmental monitoring system. There are lots of monitoring systems because every organization has every monitoring system. So here basically we'll study about environmental monitoring system. So the factors which we should consider are the acceptable time delay is likely to range from true real-time monitoring to manual sampling with a following laboratory analysis. Number 2, the requirement to control quality may range from showing pure raw data to a complete quality assurance or quality control procedure. Next, the last one is there is often a distinction between manual and fully automated data sampling systems. So whatever method we use for the actual monitoring, the process involves the following 4 steps. Number 1, a communication task which takes data from a sensor. Sensor means other information sources and communicates it to a receiving monitoring system. Number 2, pre-processing the data using steps such as calibration, checking and formatting. Number 3, storing the data in some sort of database. 4, presenting the data in an appropriate form to the users. So, GIS is ideally suited as a tool for the presentation of data derived from distributed measurement stations, for example, field-based water quality sensors. So, environmental monitoring operations are typically very expensive to set up and also to maintain. So, budget constraints often mean that monitoring programs have to be scaled down and then many systems are barely adequate to meet their objectives. Chemical parameters, for example, are frequently of interest to those who study the environment, but unfortunately, appropriate measurement instruments for such parameters are often very expensive to purchase and also to maintain. So one possible solution to this problem is to combine a reduced field-based monitoring program with mathematical modeling. Often the use of GIS for environmental monitoring is restricted to the presentation of data and also to the creation of pretty maps. So the inherent powers of GIS as a tool for data integration and analysis are very often underutilized. So the fact that monitoring systems often stop the data analysis process when adequate quality control of the incoming data has been performed prevents, for instance, environmental authorities from using GIS to do further investigations for the causes of pollution. So hopefully the creation of more and more databases with spatial information will gradually change this. so that the information is on. So GIS is also a valuable tool in the decision making process. So those who use GIS to present environmental data as maps or graphs clearly need to be aware of the issues associated with the classification, symbolization, and also visualization. So not least because they can affect the conclusions people draw about the data. GIS is used to a much smaller degree as an active component of environmental monitoring systems. As the field matures, it is to be expected that environmental monitoring and GIS will become much more closely integrated or interrelated. At the same time, GIS are becoming more and more user-friendly, making them much more relevant as a tool for non-GIS experts, such as senior managers and domain experts from other professional areas. All in all, GIS will be a component of every environmental monitoring system within the next few years. So this is quite simply because this type of data calls for the utilization of GIS capabilities, and when one considers that GIS is becoming simpler to use and much cheaper to buy, it is hard to imagine a future for environmental monitoring systems without GIS. So about GIS and detailed study of GIS, that will be watching 2 to 3 videos on GIS which will help you to understand more. Next topic is Human Development Index, HDI. So HDI is a statistical tool which is used to measure a country's overall achievement in its social and economic dimensions or perspective. So the social and economic dimensions of a country are based on the health of people, their level of education attainment, and their standard of living. Here, as you can see, HDI, that is Human Development Index, is basically life expectancy at birth, average education level, and standard of living. So the HDI was created to emphasize that people and their capabilities should be the ultimate criteria for assessing the development of a country and not the economic growth alone. The HDI can also be used to question the national policy choices, asking how two countries with the same level of GNI per capita can end up with different human development outcomes. So this contrast can stimulate debate about government policy and priorities. So the Human Development Index, HDI, it is basically a summary measure of average achievement in key dimensions of human development. That is, a long and healthy life, being knowledgeable and have a decent standard of living. The HDI is the geometric mean of normalized indices for each of the 3 dimensions. The HDI simplifies and captures only part of what human development encompasses or entails. So it does not reflect on inequalities, poverty, human security, empowerment, etc. The HDRO offers the other composite indices as broader proxy on some of the key issues of human development, inequality, gender disparity, and poverty. So here you can see about Human Development Index, the dimensions being the indicators and the dimension index, long and healthy life, knowledge, and a decent standard of living are the dimensions. And indicators for long and healthy life is like life expectancy as birth, expected years of schooling or mean years of schooling under knowledge, and GNI per capita under a decent standard of living. Dimension index, under dimension index, the term under long and healthy life is life expectancy index, knowledge, education index, and decent standard of living GNI index. So together it forms up Human Development Index, and this flowchart is very important for your exam. Next topic is Ecological Footprint of India. The ecological footprint is the only metric that measures how much nature we have and how much nature we use. So the footprint helps the countries to improve sustainability and well-being, the local leaders to optimize public project investments, and the individuals to understand their impact on the planet. So how the ecological footprint works? Ecological footprint accounting measures the demand on and supply of nature. So on the demand side, the ecological footprint measures the ecological assets that a given population requires to produce, the nature resources it consumes, which includes plant-based food and fiber products, livestock and fish products, timber and other forest products, space for urban infrastructure, and also to absorb its waste, especially carbon emissions. So the ecological footprint tracks the use of 6 categories of productive surface areas. So the 6 categories are cropland, grazing land, fishing grounds, built-up land, forest area, and carbon demand on land. On the supply side, a city, state, or nation's biocapacity represents the productivity of its ecological assets, which includes cropland, grazing lands, forest land, fishing grounds, and built-up land. This area, especially if left unharvested, can also absorb much of the waste we generate, especially our carbon emissions. So both the ecological footprint and biocapacity are expressed in global hectares. That means globally comparable standardized hectares with world average productivity. So each city, state, or nation's ecological footprint can be compared to its biocapacity. So if a population's ecological footprint exceeds the region's biocapacity, that region runs an ecological deficit. Its demand for the goods and services that its land and seas can provide, fruits and vegetables, meat, fish, food, cotton for clothing, and carbon dioxide absorption that exceeds what the region's ecosystems can renew. A region in ecological deficit means demand by importing, liquidating its own ecological assets such as overfishing and or emitting carbon dioxide into the atmosphere. So if a region's biocapacity exceeds its ecological footprint, it has an ecological reserve. So about ecological footprint, for that also we'll see 2 to 3 videos. So ecological footprint of India versus other countries. After China and USA, India has the 3rd largest ecological footprint in the world. China's share of ecological footprint, which is a measure of humanity's demand on the planet, is a massive 19%, followed by USA's 13.7%, and India is at 7.1% according to the Living Planet report of 2014. The top 5 countries which include are Brazil and Russia, which makes about half of the global total. So, humanity currently needs the regenerative capacity of 1.5 Earths to provide the ecological goods and services we use each year. The report brought out by WWF and Global Footprint Network says so. So China is ranked 76 in its per capita footprint but has the world's biggest national population and hence has the planet's largest national footprint. India shifts from having the 136th largest footprint per capita to the 3rd largest in total after multiplying population with per capita demand. So this is your weekly assignment number 2. You have to explain the main components of GIS and also explain the carbon footprint. Explain the main components of GIS and explain the carbon footprint. The last date of submission is mentioned here. CR is requested to collect the assignments and send it to me, and also the name of students who have not submitted along with their names and enrollment IDs. You have to write the answer. Then you have to scan the answer and then you have to send it. Okay? You have to write the answer. You can't just write it in a word. You have to write it in your A4 sheet or any copy. But you have to write it and you have to send it. Last date of submission is given here. So now we'll go through 3 to 4 videos related to our topics for your basic understanding, and also if we can't complete it in this class, we'll be continuing the videos in our next classes. And now you can give your name and you can give your attendance in the chat box with your full name and enrollment ID. So that's all. Thank you.
This video will cover the definition of GIS, the origin of GIS style analysis, and some of the common file formats of GIS data. What is GIS? The 21st century has brought with it many exciting technologies. The advent of the computer has allowed us to connect with people around the world and has allowed many industries to create new technologies to improve their efficiencies. The geography world had its own response to the digital age, Geographic Information Systems, also known as GIS. GIS is the use of technology to collect, manage, analyze, and display data. Unlike other data management platforms, GIS technology allows for spatial components of the data, like their locations or extents, to be a component of the analysis. According to Esri, one of the major GIS software companies, GIS systems have 5 major components: people, aka GIS experts, the data they are working with, their methods of analysis, the hardware or physical devices they are using, and finally, the softwares or computer programs used for analysis. Put these 5 together, and you have the working components of a complete GIS system. GIS platforms are incredibly useful because they allow the user to overlay multiple layers of data and understand both how the layers relate to each other and how each of them exists in space to get a fuller picture of phenomena in the real world. What is the origin of GIS-style analysis? GIS analysis is mainly known for the inclusion of multiple data layers and the inclusion of spatial characteristics in data analysis. Though GIS-style processing is much more popular now since we have a variety of powerful softwares to help us do it, the use of the multi-layer spatial analysis approach was being employed long before the computer was invented. The first use of GIS-style thinking is credited to a 19th century physician named John Snow, who used mapping and spatial analysis to halt the spread of cholera during an outbreak in London. He mapped the residences of all the victims of that particular outbreak and found that all the victims were clustered around a shared well that happened to contain the contaminated water. His brilliant use of spatial analysis was able to stop the spread of the disease and is a great example of how GIS technology and analyses methods can be used to solve problems in the world. What kind of data can I expect to see? GIS platforms can analyze both spatial and non-spatial data. GIS platforms have the ability to analyze many types of data that come in a variety of file formats. Before diving into the world of GIS, it is important to understand the 2 major types of spatial data file formats you will see so that you understand the kind of data you'll be working with. These 2 forms are vector and raster. Vector data comes in a layer that is made up of specific discontinuous shapes. They can either be points, lines, or polygons. Each individual shape represents a unique piece of data. Vector data is generally used to represent phenomena that doesn't continue across the entire space. Point data is often used to represent cities, line data is often used to represent roads, and polygons are often used to represent swaths of different land cover types. The second data type, raster, is a continuous layer made up of pixels, where every pixel has a value. JPEG is a common example of a raster dataset, something you've probably worked with when dealing with photographs on a computer. The pixels that make up the image can come in various sizes. The smaller the pixel, the higher the level of detail or resolution the image will have. Raster datasets are useful when continuous data needs to be represented, like when one is working with altitude or climatic data. Before you pick your file format, it is important to understand how you need the data to be used and visualized. You should pick the data format accordingly. In conclusion, GIS is the use of technology to manage data. It combines multiple data layers and spatial information to enhance analysis. Though today, GIS technology is largely